Hello, friends. It is Ben. I am recording a video here for the elementary functions class. As you can tell, I have my glorious studio here, which is just my basement. Okay. In I don't think any of y'all have been subjected to these videos before, but what I'm doing is essentially running through the sort of things I do in class. I've got problems for us to look at that I will work out. And I need you, because you don't get the benefit of having the one-on-one, the actual face-to-face time here. I need you to treat them slightly differently. Every problem that comes up, treat them like you do the even-numbered problems that come up. See what the problem is. I'm going to give you a PDF, okay? A couple of different options for the PDF, actually. And try the problem. See if you can figure out what's going on. In theory, you will have read the textbook because you are told for each day of class which sections of the textbook we're covering. So hopefully you have read the textbook before starting this, or at least looked through it to see some of the formulas or something, okay? So when a problem comes up, pause this video and try to work it. When you run into problems, it is not your fault that you don't magically know all this stuff. You should take that as something to spur you to figure out something. And then when I give the solution to it, then you hopefully will figure out whatever it was that was just that little thing standing in the way. Okay? That's your strategy. We're going to get at it. So let's get ready here. And I need to tell it that I'm going to share screen, and we have to hope that that does what I think it's going to do. So share screen. No, I think I just tell it to share. And and I have to download a plugin while I'm trying to do this. Okay. Well, so I've got the little beach ball, and I have to be honest with y'all, I'm not going to edit this out. I'm just going to try to go ahead. Okay, it says it's going to do it. And it says Zoom is receiving it. So let's see what happens. So Zoom thinks it's receiving something. And yes, it got it. Okay. Sorry about that. That took a minute. So as you'll recall from a previous day's lesson, we talked about this idea here that we have the x-axis and the y-axis, and we talk about an angle here having a terminal side, and the angle that that terminal side makes with the initial side, if it's a rotation counterclockwise, is a positive angle. All right. And so if we go ahead and think about going the opposite direction, then we'll have a negative angle for it. But notice that these two angles that we have, wow, that does not say, this is hard for y'all to read, I'm sorry. Here we've got that 360 plus 45 would be another representation of the exact same angle. And notice that the difference between 405 and 45 is 360 degrees. But if you take and subtract 360 degrees from 45 degrees, then you would get this negative angle of negative 315. Okay, so coterminal angles are going to differ by multiples of 360 degrees, because notice that this positive 405 and this negative 315, the difference between them would be 2 times 360. So, all right, keep that in mind, and keep in mind the whole idea of the x and y axes, right? So here we get to ask the question, what quadrant is negative 300 degrees in. So the thing we have to think about is that negative means rotating around clockwise, not counterclockwise. And so when we talk about this one, since it's negative 300, we think about negative 90 gets us to here, but negative 180 would get us to here. So negative 270 gets us to here. Negative 360 would be a full rotation. So we're actually looking for something that's between the 270 and the 360. So we're going to think about our angle as being here. And that's the, wow, that was not a very good drawing, sorry. That's our negative 300 degrees. So negative 300 degrees is in quadrant 1. Okay. So that's how we figure these out, is we think about which direction we're going, and then we look to see what it's between. You don't have to be exact. You just have to get pretty roughly in the neighborhood. Okay. So I'm going to try taking this out of the way for the next part so that we can do another one here. So the next part on this one says 7 pi over 12. And so what you need to think about is 7/12 of pi. So pi is going to be this angle here. When we take and say 7/12 of something, we have to think about that fraction. So 7/12, write it out. 7/12 is actually going to be 6/12 plus 1/12. 6/12 is really 1/2. So we're saying that the angle we're looking at is 1/2 pi plus a little bit more. So our angle we're going to think about is in here somewhere. 7 pi over 12. And so if I go back here and write this down, 7 pi over 12 radians is in quadrant 2. By the way, I've super assumed here that you know quadrant 1 is in the upper right, quadrant 2 is in the upper left, quadrant 3 is in the lower left, quadrant 4 is in the lower right. Okay, it goes around counterclockwise like that. But that's what you do on those two. Now, the next question, you need to work through there. So pause and make sure you work through it. Oh, no, that's right. You paused and worked through the previous one too, didn't you? Okay, good. So for this here, you're just you will have also paused, and we'll figure out what quadrant is 550 degrees in. Well, if we take and say that 550 is equal to 360 plus something, it's not 360, it's not 2 times 360, right? That'd be 720. So this is 360 plus, I think it's 190, right? So that means the angle we're thinking about is 1.5 and then a little bit more. Okay. So our angle that we're thinking about is a full rotation plus a half rotation and just a little bit more. So that would mean that this is in quadrant. Think about the numbers. 1, 2, 3. Okay. All right. And I'm going to try to pull that out of the way so that we can do the next piece without worrying about it. So the next one, we're talking about negative 2 pi over 3. And so think of that as negative 2/3 of pi. So that means it is negative. So you're going clockwise instead of counterclockwise. So going over this direction, but we don't quite get to a full negative pi. So it stops somewhere in here. And so we would go ahead and put that in. I should have made that line appear there. And then we'd say the negative 2 pi over 3 is in there. So negative 2 pi over 3 is also in quadrant 3. All right, cool. Okay, so the next thing here is finding two angles that are coterminal with 8 pi over 3. Helps if you know where 8 pi over 3 is before you get started. And it's positive, and it is 6 pi plus 1. Damn it! Computer, stop trying to help me. Okay. It is, and then I messed it up. Sorry. I need to go ahead and write this. 8 pi over 3 is equal to 2 pi 8/3. Yeah, I should have written it like that. 8/3 pi. 8/3 is going to be 2 and 2/3. All right. So if I'm drawing that here, 2, there's a half, and there's the computer trying to help me again. God damn it. There. So here is a line that is more than a half, because 2/3 is more than a half, into that next pi rotation there. So our 8 pi over 3, first of all, is here in the second quadrant. Now, because we are getting two coterminal angles, and coterminal angles differ by multiples of 360 degrees, that means when we do them in radians, they will differ by 2 pi radians. So we can take 8 pi over 3 and subtract 2 pi from it and get 2 pi over 3. But we could also take 8 pi over 3 and add 2 pi to it, which means we got to do least common denominators. Sorry about that, but you end up with 14 pi over 3, okay? And if you came up with different ones, just check to see, did you put a multiple of 2 pi in there? You could have added 4 pi or 6 pi. You could have subtracted 4 pi or 6 pi. I just chose the easy ones because that's what I do. All right. All right, this one here, give two angles that are coterminal with negative 90 degrees. So I just got the signal from my pencil that it is about out of juice, which is thrilling because that means that I'm going to run out in the middle of this. Okay. So we're getting two angles that are coterminal with negative 90 degrees. If you remember, negative 90 degrees is going to be the negative y-axis there. So we're thinking about this down here, right? But you can take negative 90 degrees and you can add 360 to it, and you'll get 270 degrees. That would be this angle here. Or you can take the negative 90 degrees and subtract 360, and you'll get negative 450 degrees. That would be this angle that goes around an extra time like that. Both of those are correct, and you could come up with a bunch of other solutions to it as well. Okay. All right, this guy here, what's the reference angle for 200 degrees? So for reference angle, the reference angle means the positive acute angle a terminal side makes with the x-axis. Okay, so in short, you are going to think about where your terminal side is for your angle, and you look for the nearest portion of the x-axis. If you need me to define what nearest is, I can't. All right, nearest means nearest. Okay, and you subtract one from the other and get a positive number. So biggest minus smallest. I do not want to give you an exhaustive list of all the possible formulas in the world there are for this, because it would mean memorizing infinitely many formulas. Just figure out which one is nearest. What is the closest multiple of 180 degrees? Or what is the closest multiple of pi, right? So let's take a look for these two and place them. And I have to stop sharing so that I can pause to answer